Is it okay if I record the session?
Okay.
Thank you.
Sure.
Okay.
Thanks. So, yeah, one of the key aspects of machine learning is that once we have a model, how do we use it in production? And one simple way for that is to use a server where you host a model and you send the data to the server at the place with the right location, and you pass the data and get back the prediction. So that's what today's topic predominantly is about. So it's not, we won't be doing math theory or writing code for building the model, but we'll be doing this very important task that once the model is ready, how do we use that? Does that sound okay?
Okay.
Yeah.
Yes. Okay.
So essentially, there is one micro framework that's very popular. It's called Flask. Have you guys used Flask before?
No.
No.
Okay.
No.
Has anyone used HTML and JavaScript before?
Yes. Yes.
Okay, awesome. So if I get stuck, please help me out with the JavaScript. So Flask is written in Python, and it's the popular mode for hosting machine learning models in Python. So we'll go through 3 examples. One is where we just set up Flask, and then we use a web app. Essentially, we go to the URL where Flask is listening, and we get an output. Once that is done, the second thing we'll do is we'll set up another script in Flask and an HTML and JavaScript web app where the web app will just take any text entered, let's say the name, pass it to Flask, and Flask will then add some text to it, return it to the web app, and it'll write something. The third is sort of what is something you would use for deploying a model, where you would write a web app which sends an image to Flask, and Flask will then run it through a model. In our case, is the same VGG 16 model which won the ImageNet competition in 2014. And it'll give us some output, and we'll display the output in the web app. Does that sound okay?
Okay. Okay.
So
So,
why,
Avneet, what are just the weights? No,
say that again, please.
what are we deploying?
So that's a good question. In this particular case, the so as you point hinted that the model can be saved just as the weights, or it can be saved with the width and the architecture. In this case, what I have is the weights and the architecture, the whole thing complete. So that's what we'll be deploying. Sounds okay?
I thought, how was the weights alone useful? I mean, the architecture has to go with the weights, no?
So weights are useful. Yeah, correct. We need both. So if you know the architecture and you have it created in, let's say, by yourself in a different variable, then you can load the weights of another model into this architecture, which is actually the same architecture as before. So, but essentially, yeah, you need both the weight and the architecture to do the prediction and other tasks.
Okay.
So, yeah, let's start. So the first thing we will need to do together, do you guys have PyCharm?
No.
No.
Okay. So PyCharm is the most popular IDE for Python. Would you be open to installing that? It has both a free version and a paid one. So I normally go for the free version.
Okay.
Okay.
But Keras itself doesn't offer any deployment. Huh?
I mean, this is the deployment is sort of independent of Keras. What Keras does is it allows you to save the model and it recommends HDF5 format. And Flask is just a microservice and PyCharm is just an ID. So we don't have to use PyCharm. We could have used something else. It's just one of the things that is popular and that I tend to use.
Okay, carry on, Avneet.
Okay. So the first step is if we can download PyCharm, install that. And once we have that, then we need to install libraries. Well, then we create a project and we install libraries by going to settings. And then this, can you see the plus sign at the top right? Sorry, that's once you have installed PyCharm. So I'll wait for you guys to let me know that PyCharm is there.
Okay.
Shantanu is trying to join. Radha, are you able to join?
Yes, I am here.
Okay. So what we are all doing right now, so today essentially we are learning how to deploy models to a web server so that once it's in the web server, then any app can send it data written in any language and receive back from it. So that's what we are focusing on. And the first task is to download something called PyCharm. So that's what everybody's doing right now. Could you also use the link that I'm sharing? It's actually already shared. I'll share it again.
Okay.
And install PyCharm.
Okay.
Avni,
Mm-hmm.
do we need to that the free trial we should not the pure development one we need to install?
The one that's called Community.
Okay, fine. Thank you.
Yeah, that one is free.
Yeah, that's okay. Thank you.
Hmm. Are we installing? Is anyone done?
No, it will take some time because it does 300 plus MB. So
Okay.
it's still downloading it.
Okay. Maybe I'll start while it's downloading later.
Mm.
You can see the video and sort of follow
Mm.
that.
Mm.
So let's see. So once you have downloaded and installed PyCharm,
Installed it, but under settings, where should I go?
so the next step would be to create a new project.
I've done that.
Okay. After that, so that if you can, so at the Google Drive, there's a project called Flask Apps. There's a folder called Flask Apps.
Yeah.
So if you copy everything from there to your new project,
Okay.
so now your project should look like this.
Okay.
Okay, cool. So yeah, first we will take a very simple case. If you open sample app.py, so this is essentially a very simple Flask app. So we're just importing Flask from Flask, and we are instantiating an object. The next step, what we're doing is, we are saying this is the path /sample. So once we have Flask running, then it will listen at this path. So localhost underscore 5000 /sample. And right now, this is very simple. When we go to that path using a web app, web browser, then it'll just run this function and it'll just return this text. This is just saying that I can basically run it from this file itself and it'll run all these commands, even though these are all just functions mainly. So I run this, and now it's saying that it's running on this location. And all I do is so all you type is essentially localhost. Let me put it in text. It's http:// and if you click there, then it'll just show Flask is running. Could that work for anyone?
I'm a little bit behind here. I'll work with you later.
Okay.
I'm downloading the sample. Just 2 minutes.
Sorry?
I'm downloading all the files from Drive.
Got it.
It'll take some time here.
Okay. But this is a very simple and straightforward Flask app. All it's saying is it initiates the object, and then it says, if you go to this path, then I'm going to just return the string. So
Okay.
we went to that path, and the browser was given the string, and it displayed that. Now we'll go back and stop running. The other thing is you can sort of see what happened here. So I'll paste this on Skype so you can see what's saying. It's basically giving the IP address where the browser came from. giving you the timestamp. It's saying get, so the browser is just getting data. It did not send anything. And this was the path which was used. It was just providing simple information. Now I will stop this. And we will go to another app called Hello. So here, it's again very simple. We import some things from Flask. So request is what the Flask service will receive. So JSONify. So the communication is happening essentially in JSON. Are you guys familiar with JSON?
Yes.
Awesome. So we're just passing along JSON between the web app and the Flask server, and then just basic Flask. So again, we do the same thing. We instantiate a Flask object, and now we say the route or the path is hello. Last time it was sample. This time it's hello. And last time, do you remember what the method was?
It's a get.
Correct. This time it's a post. So we'll essentially expect to receive data from the web app. And anytime we get to this hello, it's going to run this function. And when the function is hit, all it'll do is it'll take the request and convert it into JSON. Put it in message. Now it is expecting JSON is a dictionary, key value pairs. It is expecting the key name to be there. And it'll just take the value of that, put it in name. And then we create another object, response, where we just say greeting, hello, and the name which we had received from the web app. We just add it here. We take this response, we use JSONify on that, and we return it. So all this is doing is, anytime the web app goes to hello, the web app will send its request, and that will have key value pair with the key name. And that name will be added to the greeting message. And this will return a JSON object. Does that all sound okay?
Okay.
Okay. So this is what's happening on the Flask side. Now we need something on the HTML side. So you guys already know this very well. This is just a head,
Yeah.
and this is the title, which will show up as in the tab. And the body, we have essentially three things. We have an input button with the ID name input or input text box. Then we have a button that's called name button. The ID is name button. It displays submit name, and then we have a paragraph. The ID of the paragraph is greeting. The next step is the JavaScript. So here it's just saying when the name button is clicked, then the text box name input, it had a value. Create a key value pair where name is the key and whatever was in the text box is the value. Create that into an object called message. So Flask was expecting a post method. So here JavaScript is using post. That Flask file was at hello. That was a path. So this is where the JavaScript will send the data at localhost 5000 @/hello. It's going to JSONify and send it in the message object. Once it gets back a response, the response will have something called greeting. So here, response had a key greeting. So here again, we basically go for the greeting, which has the text. And here, greeting was the ID for the paragraph. So it just changes the text value of the paragraph to what it received from Flask web service. Does that sound okay?
Okay.
All it did is there's some stuff in the text box. When we press the button, that is sent at the path, hello, and the response is picked up. And the paragraph, which had the ID greeting, now its text is changed to whatever the response was. So let's go and run the hello app. Okay, so now it's running. So our HTML file was under the folder static. So the folder I've shared for Flask apps has a subfolder called static. So that's where we have the HTML file. That's where we went. We put a word in there. This is the web app. It's sent it to /hello where Flask is listening. It took that, it added it to the greeting and sent it back. And the paragraph here was given the text, which was the greeting. So in this case, we were able to send the data to Flask and get something back. That sounds okay?
Yeah.
Right. So now let's get to the fun part. So this is essentially the Flask script where we are going to run the model on the server. And so when you download all these files, what you'll notice is one thing that I did was I went to, so the original plan was to take the VGG model that we had changed to dogs and cats and use that to predict dogs and cats. I sort of changed that to actually using the original VGG model. And to get that, all I did was we have these commands from before, from a previous class. I just told Keras to get the VGG16 model, and then I saved this as a H file. So this is commented out. It won't run in the script. So that's what I did to get the model, which is already there in the folder that you will download. So you don't have to do this to run this, but just to let you know. So here, what's going on is essentially so one quick question. This was something recently asked to me. So when you want to respond to predictions from model, do you want to have the model loaded into memory, or should you have the model in the hard disk and load it when you need it?
You can have it in the hard disk.
How it goes from disk? It has to be in memory.
Sorry?
I think it has to be in memory.
Yeah, so generally the practice is to have it in memory. And that's under the expectation that you want a quick response time and you would be getting a good number of requests. So getting it out of the hard disk and putting it in memory every time might be an overhead. So in general, that is the preferred method. There may be special cases where the model may be very small and it's rarely used, in which case we may choose not to do that. So in our case, what we are doing is we are initially having it in memory. So one function is to load the model in memory. Another is to do some pre-processing because the web app will send a bunch of bytes that has to be converted into an NumPy array in a form that the model can use. And then there's a predict function which will give the image data to the model, get the prediction, and return the predictions to the web app. So these are just some of the libraries. The data is encoded in base 64. So we'll decode that. We'll need NumPy, IO. The pill, when I tried to download and install it, didn't happen. Instead, I installed Pillow, that worked. So that's a little thing commented. So in case you try to install Pill and it doesn't work, just you can install Pillow.
What is meant for?
Sorry?
What is the use of the pillow?
Image processing.
Yeah. I think it's called Python.
Image library, yeah?
Yeah, it's an image library. It's for processing.
Yeah.
Isn't OpenCV the same thing, Divya? Or what is this?
This is a layer above OpenCV, and this can go together. It's just opening, and it is not as complicated as OpenCV.
Mm-hmm.
Thanks for sharing that. These are just Keras stuff and the same three things from Flask, plus we have TensorFlow. So after that, we have the same thing. We instantiate an object. So here under get model, we're just creating a global variable model. So then we load the VGG16 H5, and this is the original model from 2014 that predicts about 1,000 categories.
This looks like Java, Avneet. Is this what it is? Or is it Python?
This is Python.
It's Python.
It's definition, huh?
Mm-hmm.
I thought there was a Java kind of structure.
Java script.
Mm-hmm.
So once we have loaded the model, it'll just print. And these, I was getting an error before, so apparently there was an error with TensorFlow running the model. So adding these two things was suggested in some forums, and that took care of the error. So that was also required. In terms of pre-processing, VCG requires the image to be 224 by 224. So we want to convert the image to that size, target size. it's expecting RGB. So if it is not RGB, then that has to be done. And then we convert it to an array. And so this is a numpy array. That's what this function returns. So here we're just saying get model, and the first time when we run this script, it will essentially load the model and keep it in the global variable. So that way, the model is loaded just one time, and it's available for the function to call. The path where Flask will listen defined as predict. And this is the function. Just like before, we'll get a request. We'll turn it into JSON. The key in the message, so that was saved as message. The key in the message is image. And right now that's encoded. So we decode that. And then we have the decoded image. Once we have the decoded image, this is not something from an image file. So we add some more stuff to that. And then we give it for pre-processing. And give it the target size that VTG is expecting. So then when we run the model.predict, so we had loaded the model and we run predict on that. We give it the image. What we get is a numpy array. So we convert that to a list. And what we get is a list of lists and prediction. So originally this was meant for two categories, cats and dogs, which was the model we had built. But since I'm using VGG16, this actually returns 1,000 values. So this is the first prediction, the second, so until 1,000. So there were 1,000 categories. And the prediction now has probabilities for each of the 1,000 categories. And what we are returning right now is only for the top two categories. So we just create this object and JSONify it and return it.
So how do we know that the first and the second one is dog and cat?
So that is, in this case, that's not uh, dog and cat, but in
Oh, the highest prediction, no?
so this model was originally meant to have only two categories, but I changed the model. So ideally, it should have done what you're saying. We should have found out the highest prediction, and we should have found out the category corresponding to that. So essentially, what this is going to return is 1,000 probabilities, and those correspond to the VGG model, which had 1,000 neurons in the last layer. And
Yeah,
those
so the first and
1,000,
second for that was dog and cat, huh?
no, this you can think of it more as a bird, because the model that we had built in the second class, that only had dog and cat.
Correct.
So originally I was planning to use that model.
So there, it's guaranteed only two outputs will come.
So the prediction right now has 1,000 outputs, but I'm only picking two.
But how do you know the first one is a dog?
Actually, it isn't.
It's not. Huh? Okay.
Yeah. If we had used the model that we all had built in the second class, in that we had two output neurons, where the first one was given images of dog, and the second one was given images of cat. So that would have corresponded perfectly here.
Okay, fine.
But I swapped the model, so this doesn't exactly apply anymore.
Okay.
So I'm just picking, I don't know what the top two categories are for VGG model. So whatever they are, those should have been here. Actually, this code, and it's a very good homework assignment. So here, what should be done is to find, and it's a very simple line of code, just find the highest probability and get the index for that. And then we would need another dictionary which has, or a list which has by the index what categories are there in VGG. Pick that category and return that. That would be the right code. But yeah, right now, this is more of, this was more meant for the dog and cat example, but I changed it to the last minutes.
Okay.
But thanks for clarifying that. I must have, that's a little bit of confusion in this right now. So that's the backend. And the backend is just saying when we start the server, then we load the model and it listens on /predict. At that place, we send information about the image. That information is processed and it's run through the model. We get the predictions and we return it back to the front end. Does all that sound okay?
So you need the UI for it, no?
Yeah, so this is the front end. That was a perfect segue. So for the front end, we have the same thing. We have the head, which just has the style and the title. It shows up in the tab. Then we have the body where we have HTML and JavaScript. So here we basically are going to pick an image, and then there's a predict button. And then we have paragraphs for dog and cat, which was the model I had planned it for, which was the model we built in the second class, and have their predictions. So here it's saying, what do we do when the image is selected? So it's just reading the image and putting it in the right format. So right now, we expect it to be a PNG. And we're ensuring if we do it multiple times, that the text is empty. So we can fill that part in. And when we click on the predict button, that's where it takes the image which we had gotten from here, put it in an object, use JSON on that, send it to predict. That's the JavaScript using the post to send the image information. And when it gets the response, basically it takes the response and the prediction. And we had put it in dog and cat, so it gets those values. And those are put into the text values of the two paragraphs. So it's pretty straightforward. Allows you to provide an image, sends the image, receives back the predictions, and receives back, we send it back two predictions, so it takes those two and displays them. So let's run this thing. Okay, so the model has loaded, here it says, and it's running. HTTP / localhost, and we go to predict vgg16.html. So what I did was I actually found the images which were used for the 2014 competition. And one of the categories was ant. So here I just picked up this ant. And now we click the predict button. And these are the top 2 predictions out of the top 1,000 which were returned. Ideally, as Senthil mentioned, what we should have done is from those 1,000, pick the one highest and find its corresponding category and then display that here. But either way, what we saw was that we had a Flask script which loaded a model, got into memory, and when the web app sent it the image, it processed the image, got into the right format, ran it through the model, got the predictions, and sent it back to the web app, which were displayed here. So those were the 3 things I wanted to share. First was how to use just a simple Flask returning a string with the get method where nothing is sent to Flask. The second was the web app sends some text to Flask, and Flask adds some greeting to that, and returns that back to the web app. And the third was where Flask is running. It has loaded a Keras model saved as SDF5, and it receives images, it processes them, it gets the predictions, and send back. So in real life, essentially, you'll just have this Flask thing running where it has loaded the model, and it'll be listening at a path. So you send it JSON, and that JSON will have all the features for the model, all the data required for the model to make the prediction. So the model will receive that prediction, will receive that data, it will generate the prediction, and send the prediction back. And that's typically how most of the people in the industry seem to be using it right now. So this now allows you, from what we have learned, is that we learned first how to build a simple neural network model, then how to build a model to categorize images as cats and dogs. And now that we have that model, we now can deploy it and use it in production. Those were some of the key tasks. Do we have any questions on what we did today?
No.
Okay, awesome. Thank you so much, and thanks for the questions and also for providing some of the answers. Next week, so Mom is visiting here. She'll be heading back in a few days. So next weekend, I'll spend some time with her. She's been very kind and patient with me. So we won't have I won't be able to give the class next weekend, but the weekend after that, we'll start again. And then we will start learning about. So what we did right now are called CNN, convolutional networks, neural networks. What we'll do after we come back. So next week I won't be there. The weekend after that, we'll have the class again. We'll start about recurrent neural networks, and they're used in a lot of places like language and some other things. But yeah, language is a big application for recurrent neural networks, so we'll start from there. So we won't have a class next week. We'll start the week after that again. So thanks for joining the class. Have a nice weekend.
Okay. Thanks, Avneet. Enjoy your time.
Thank you.
Thank you.